Here is your free response question for the day. So for this question, you're given a graph, and that graph is the graph of f, and it tells you in the question that we have two line segments here, and then three different parabolas that form the other parts. Now in the question, it tells you that a, the area of a, might as well just write it, is equal to 3, and the area of b is equal to 5. So it tells you that area. And it gives you an equation for the last one from 1 to 4 that we could use if we need to find the area. Okay, so question A says, and you're given what G is defined as. So G is the integration using F. So the first question is G at 0. Why don't you see if you can set it up first? Then you can press play. And now see if you can now answer it. If you know you can't answer it, then follow along. If you think you can answer it, try it, then press play. So to integrate off a graph means to find the area under the curve. So from -4 to 0, first of all, I have a triangle from -4 to -1. So that's half the base, and the base is 3, and the height is also 3. So right away, I got 9 over, let's make sure it's accurate here, 9 over 2. We'll do that in the next step, right? Maybe that way. Then I also want to notice that that area I just found was above the axis. So that's why it's a positive number. Then we also have this parabola. Notice this parabola is below, and we're told the area is 3, but we need to write that as a -3. So the full answer is 9 over 2, take away 3. That's fine. Or you can write it, get common denominators. If you like, multiply top and bottom times 2, and you get 9, take away 6. And the integration there is 1.5, or 3 over 2. What the second one? Do you want to try this one? So why don't you try this one? Set it up, and can you find the area that's asking for? All right, for those that need support right away, you can follow. So we're going to substitute 4 in. Now, we already know -4 to 0 is 3 over 2. So we already know that part. Everything else we're going to add in terms of finding it. So the next one, we're told that B, the area is 5. And then the last part I need to do goes from 1 to 4. And this one's going to take a little bit more time. So we have 3 over 2. We have 5. In order to do this, we're not going to do it off the graph, but with the equation. Now we're told what f is in that area. It's -x squared plus 5x take away 4. So I know whatever answer it is, it's going to be a positive area. I'm just going to use parentheses to help separate it. Can you integrate this? So -x squared. So it's going to be -x cubed divided by 3. 5x, that's 5x squared divided by 2. And 4, and that's -4x, and you're integrating from 1 to 4. So there's the setup. And then I'm going to use, I might need a little room. I don't need to simplify this at all. Oh, we're using t, so I should really use t here. So let's make sure t's are there. So we have 3 over 2. We have 5. And now I'm going to do substitution. So we're first going to substitute in 4. So that's negative. And that's 4 cubed over 3 plus 5 4 squared over 2 minus 4 times 4. Excellent. Put parentheses around that. Subtract. Now plug in 1. And you have your answer. And you don't have to simplify it. But you showed that you can integrate off a graph by finding area, or you can integrate by using the anti-power rules or other integration rules and do it with algebraically rather than off a graph. And again, you don't need to simplify it. Good job. All right, part B. Find that. Part B says, find the absolute minimum value of G on the closed interval -4 to 4. So remember, g is defined as, so -4, the integration from -4 to x, f of t dt. So what x value would give you the lowest number possible? So let's look off here and understand it. So first, when I look off the graph, when its area above, the value is going to increase, then below it's going to decrease, then above, and then again it's above. So we're the only two logical places that we could find the absolute minimum. So one would be at the very beginning before you start. What is that value right at the beginning before I increase, then decrease, and so on? The only other logical one defined is this one. And when you look at it, I think you can see it's not going to be true, but let's look at it. That you can see when it decreases under the graph, the very end, it decreases all the way, decreases. At what x value would it be at its lowest in terms of this area? And that would be at 0. Notice how it just keeps, even though the graph is increasing, the area is all below. So this whole part below is decreasing the whole time. So the two things we'd be looking at are at -4 and when x equals 0. Now, if I would look at it using some number sense or some area sense, notice this area A is smaller than the area of the triangle. So this area of the triangle increases, but when it decreases, it's not going to be back to whatever the answer is there. Because it's smaller than this area, when it decreases, it's still going to be a number that's bigger than what we started with. So we start with a number, it increases with that area, then this area will go back down, but because the area is smaller than the triangle, it's not going to go way back to what it was, and then when you look at the rest, it's just going to keep increasing the whole way. So I have a good sense that that's going to be my minimum value at -4. Now we can show that. So the two places we're going to look at is when g is at 0 and when g is at -4. Now g at 0 we answered at the very, very, very beginning, so we don't need to redo all that work. It's 3/2. At -4, what's the area from -4 to -4? So when the bounds match each other, that means the area is 0. So you're going from -4 to -4, so you're not finding the area between any bounds. It's the same bounds, so that area is 0. So it says find the absolute minimum on the closed end and then justify your answer. So and then why did we pick that? And you can say positive probably or non-negative. So I'm going to say the absolute minimum is there since all areas are non-negative and therefore increasing, except between -1 and 0. Then you can write down, but at g at 0 is greater than g at -4, so that you have shown that you've tried the two possibilities in that you are satisfied that the lowest value for g is 0. It increases from there, then it decreases, but then it just keeps increasing from there. But it's never going to get less than that answer. So the smallest is 0. The next smallest answer might be 3/2, and then to look at it. And then give a reason why you said that. So we're looking at the areas, and positive area means it's increasing. If it's negative area, that means it's decreasing. And so what x value gives you the smallest value? So at -4, it gives you. So 0 is your absolute minimum. All right, last part, part C. Find all intervals in which the graph of g is concave down. So when you hear the word concave down, you know you're taking the second derivative. So let's just go through this. So g at x equals, and it goes from -4 to x, f of t dt. That's g at x. The derivative know that when you take the derivative and integration, that's the fundamental thermocalculus, they undo each other, and then the variable gets plugged in. Any constant will just give you the answer 0. So the answer here is just f at x. But then that leads us to here, the second derivative for g, then would be the derivative of f. So this is to start with. Do you understand the second derivative of g means the first derivative of f? Now, for the derivative of f, when I look off this graph, what I'm looking for, so this is f, the derivative of f is positive, negative, negative, positive, negative, and so on, that I'm looking on this graph for increasing and decreasing. So can you find the ones that I care about? So at -2, -4 to -2, here at some value down there, here at some value up here, and then here and here, and then at the end, in terms of where it changes from increasing to decreasing. So where is the graph concave down? That's all it asks for. So it's concave down when it's negative. So at what x values is it negative? So from -2 to -0.5. Now are we given that? Oh, okay. So in the question it says the graph has horizontal tangents at -0.5. That's another way of saying there's a turning point. Also at +0.5, that's up here, a turning point. And at 5/2. Well, there you go. Those are the x values. I have to be a good reader to understand why did they give us that data. So that's for the last question. So again, where am I looking for? Where is it decreasing? So for concave down. So from -2 to -0.5. Where else is it decreasing? So it's also decreasing from 1/2 to 1. That's just a u, means and. Is it decreasing anywhere else? Yep, from 2.5 or 5/2 to 4. And that's it. And you can write down f at x is decreasing on those intervals. They love the words increasing and decreasing. Try to incorporate those two words as much as you can when you justify your answers. All right, great job doing your free response question with me today. Mr. G Math over and out.